This type of word problem is called a work word problem. It deals with how much work different people or machines can do in a certain amount of time. Now it's going to look a lot like distance equals rate times time problems, because just like in that case, we're going to have work equals rate times time. And you see, before we said distance equals rate times time. But if you think about it, it's pretty logical. How far you go will depend on how fast you're traveling, which is your rate, and how long you travel at that speed. So rate times time will get us my distance. Well, the work that you accomplish is the same thing. How fast you work, how much speed that you work at, times how long you actually work at that speed, will be how much work you accomplish. Now, the rate is a little bit different in a work problem. In a distance problem, we're usually given the rate, miles per hour, feet per second, meters per second, whatever. But in a work problem, we're not usually given the rate. We're given how long it takes the person to do a job. So if we read this problem over here now, you see Judy can complete the job in 4 hours working alone. Okay? Laura can do the same job by herself. It takes her 6 hours. So they tell us how long it takes for them to do one job. If I know how long it takes to do one job, then I can figure out the rate, because the rate is going to be one job over the time to do one job. So if I look back over here with Judy does one job in 4 hours. So Judy's rate would be 1/4, which reads as one job every 4 hours. So to do these problems, we know that we're going to have the work for Judy plus the work done by Laura is going to be all the work done in this job. And you see that the job is one complete inventory, so it's going to be one job. It's always going to be the number of jobs. So the work for Judy is the work for Laura equals the total work done, which is one job. Now here it actually makes it a little more sense to make a chart to hold our information before we move on to our actual equation. So I'm going to make up this chart for both Judy and Laura. And from this, our equation is going to pop right off. So I have Judy in the top and Laura in the bottom. This first box is how long to do one job. The time to do one job. Okay. Judy, if we read the problem up here, it says that Judy does the job in 4 hours. So the time for Judy to do one job is 4 hours, and for Laura it's 6. Now I put a second line down here just to separate from the parts that are going to be in my actual equation. The next part is going to be the rate. And I'm looking for rate times time equals work. And as we discussed over here, Judy's rate is one job every 4 hours. So it's 1/4. Now, since Laura does the one job in 6 hours, her rate is 1/6. The second block is going to actually be my time. Now, if we read the problem, we don't know how long they actually spend time working together, but we do know they work the same amount of time. So that's going to be our variable. So Judy worked time t. Laura also worked time t. Now, our equation is actually coming together because rate times time equals work done. Sorry about the bouncing screen. This is my first video. So we have rate times time. So Judy's amount of work is 1/4 t. And Laura is 1/6 times t. Her rate times time, that's the work done by Laura. So this is work by Judy, and this is work by Laura. And if I look at what I already discussed earlier, then I know I have my equation. Work for Judy is 1/4 T. The work for Laura is 1/6 T, and that equals one job. Now to solve for T, it's just solving the equation that involves fractions. So if I look at the problem here, I can see that I have a 4 and a 6 in the denominator. So my common denominator is going to be 12. So I'm going to multiply both sides of the equation by 12. I got to remember, of course, that it does over here, it does distribute to both parts, both terms. So I have 12 times 1/4, so I have 3t, because 4 cancels with the 12, plus I have 1/6 of 12, which is 2t, equals 1 times 12, which is 12. So I get 5t equals 12, and when I divide both sides by 5, I get t equals 2 2/5 hours. So it would take Laura and Judy 2 2/5 hours to finish the job. Sorry about this. So this is one example. So again, to summarize, we have work equals rate times time. The rate is always the time to do one job. So one job every whatever the units are, in this case 1/4 or 1/6. I add up the work because they're working together, and I find the amount of time. So Judy can do it by herself for 4 hours. Laura can do it for 6, but together it only takes 2 2/5 hours. There are more videos coming with different variations of this, but this is the basic theme on how to solve a work problem.